Hello, Year 10. Last lesson with Miss Harradine, you looked at plotting linear graphs, straight line graphs, and today we're going to develop that by looking at a particular technique for when equations are presented in a certain form that makes plotting them really super easy, and that technique is called the cover-up method. So if you look at what's on the screen, we've got two equations that we're being asked to draw the graphs for, and they have got the x's and the y's on the left-hand side and then a constant on the right-hand side. And what you've looked at so far is equations of the form y equals, for example, 3x plus 5. So the x and the constant are both on the right-hand side. So when your equation is given in this form, it's actually pretty tricky to use a table and work out points and plot them. But there is another method we can use, and that is the cover-up method. So first equation, 3x add 2y equals 12. We're going to think about what happens when x equals 0. And to imagine that x equals 0, I'm going to take my equation and I'm going to place my hand over the x's. I know that they're 0. Even if there are 3 of them, if each one is 0, my total is still 0. So that means to say that what I'm left with is 2y, and that must equal 12. So if I now divide through by 2, it makes sense to say that y will be equal to 6. So when x is 0, y is 6. And that gives us a coordinate. Gives us the coordinate 0, 6. And I can plot that. So as you can see, I've plotted that over here. When x is 0, y is 6. And this is where it's going to cross the y-axis. This is going to be the intercept. Okay, so now I'm going to think about what happens when y equals 0. And to do that, I'm going to cover up the y part with my hand. I know that they're 0. So that leaves me with 3x must be equal to 12. And then I'm going to divide through by 3. And that gives me that x equals 4. Now that gives me a coordinate as well, but this time I know that x is 4 and y is 0. So the 0 now is the y coordinate. And now I can plot that. Now what's really useful here is because I've got 2 coordinates, that is enough. I can join these up with a straight line, and that is what my graph is going to look like. So this is a technique you're only going to want to use when your x's and y's are on the left-hand side of your equation. So let's have a look at this second one here. So I've plotted 3x plus 2y equals 12, and I'm now going to move on to 3x plus 5y equals 15. So there's our equation. We're now going to start thinking about what happens when x equals 0. So what I'd like you to do is pause the video, put your hand over the x's, and work out what the y coordinate is when x equals 0. So pause the video and have a go. Okay, so you should have placed your hand over the 3x, there's 0, and that leaves us with 5y being equal to 15. Divide through by 5, and y equals 3. So I've got a coordinate of 0, 3, and now I'm going to look at what happens when y equals 0. So could you again pause the video, put your hand over the y's, and work out what x is? Okay, so you should have placed your hand over the y's, they're 0, and so 3x is equal to 15, and now I'm going to divide through by 3, and I know that x equals 5. So my coordinate is going to be 5, 0, and I'm now going to plot both of those. So 5, 0, 0, 3, and I'm going to join those up. Now there's something really interesting about this point right here. This is called a point of intersection. It is the one point where that we have a solution for 3x plus 2y equals 12, which is also a solution for 3x plus 5y equals 15. So this point lies on both graphs. And if I was asked to read this off, if I was asked to read off the point of intersection, I'd have to estimate it because I haven't got an accurate enough grid here, but I'd say, well, that's about 3.3, and the y coordinate is 1. So x equals 3.3, y equals 1 is a solution for both of these equations. Okay, so I'm going to take you through another example which is slightly different. And again, I'm going to ask you to pause the video and have a go. So on the screen there, you can see the equation 5x plus y equals 10. What I'd like you to do is pause the video, cover up the x's, cover up the y's, and work out the two coordinates that we can plot on our grid. So pause the video and in your book, work out what those points are. Okay, so you should have covered up the x's and that gives me that y equals 10. I can actually see that there's a mistake there. That should say 5x plus y equals 10. Doesn't matter when I've covered it up though, because my y value is going to be 10 and that gives me the coordinate 0, 10. And I can plot that over on my grid here. It's going through 0, 10. And now I'm going to think about what happens when y equals 0. So I'm going to cover up the y's, and that gives me 5x equals 10. And I can divide through by 5, and that gives me x equals 2. So my coordinate is going to be 2, 0. And I can plot that on the screen. And now I can join those two coordinates up, and that gives me my graph. Okay, we're now going to look at another equation that we're going to plot on the same grid. And this one is slightly different because all the examples we've looked at previously have got a plus here, an add, and we've now got a subtract. So I'm going to start off, and also I've got my y first and my x second. I'm going to start off looking at what happens when x equals 0. So I'm going to cover up the x's, and this is essentially telling me that y is equal to 2. I don't need to do any further calculation. This is a subtract here, but it's not making any difference because I'm subtracting 0. So y must be equal to 2, and so my coordinate is going to be 0, 2. Okay, when y equals 0 then, I'm going to cover up my y there, and now this subtract has made this a negative 2x. So when I divide through here, I'm going to have to divide through by negative 2, and that is going to matter because when I divide a positive by a negative, I get a negative answer. So here I'm going to end up with x equals negative 1. And so my coordinate is negative 1, 0. And now I'm going to plot both of those points. So 0, 2 and negative 1, 0. And I'm going to join those up to get my graph. And now I can read off the point of intersection here. Again, I'm going to have to estimate this. But if you notice here, be careful with the scale because this is 1 and then we skip 2 squares to get to 2. So this is 1.5. So I would say this is probably about 1.2. And then over here, we've got a different scale. That's probably about 4.3. So something along the lines of 1.2, 4.3 is the point of intersection. And remember, that is a solution for both equations at the same time. Okay, so here's your exercise for today. You're going to have to pause the video in order to do this, and then you'll get the answers next lesson. So in every case, you're given a set of axes and you're given how big to make those axes. So for the first one, for x and y, you need to draw them from 0 to 8. And then using the cover-up method, you're going to draw the graphs of these two equations, and then you've got to read off the point of intersection. So every time you're given a different instruction for drawing your axes, okay, if you don't do that, then you may not be able to fit your coordinates on. So just be careful that you follow those instructions. You don't need a set of axes done for you. You can draw these into your books where you've got squared paper. And if you have run out of space in your book now, then you might just need to draw out your axes as accurately as you possibly can using a ruler. So get these done and then check back to tomorrow's lesson to be able to mark your work.